Good afternoon, dear participant. We are now in third session of course Geospatial Technology for Climate Smart. Today, we will move ahead with more detailed understanding about how geospatial technology can help to assess agroclimatic risk, as well as what are the technology that can be adopted to achieve climate resilient agriculture. As all of we know, climate change threatening agriculture across the world and causing anomaly in crop performance due to various effects. These may be increasing new pest and disease incidence, maybe decline in the crop yield, increasing frequency of the drought, loss of natural resource, including biodiversity, as well as increasing greenhouse gas causing global warming. All these effects culminatively affecting agriculture. Let us understand how this climate change happen or what drives changes in the climate system. Mainly sun energy is the source of energy for various physical processes at the earth's surface. There are atmosphere comprising of different gases inside the atmosphere. There is a cloud, there is a soot, there are certain concentration smoke. All these act as a warming aerosol. They trap energy and re-radiate back to the earth's surface, which leads to the warming of the earth's surface. Mainly these greenhouse gases are carbon dioxide, which is in abundant, one of the most culprit gas because it lasts in the atmosphere for more than 100 years. Second is a methane, which has got very high, more than 200 times anthropogenic value of carbon dioxide, water vapor, nitrous oxide, ozone, and so on. Similarly, there are certain cooling aerosols like natural carbon sequestration to terrestrial vegetation, dust, volcanic aerosol, forest soil, and ocean body. So there is a need to be a balance between warming and cooling. If there is a balance, life sustain on the earth. If there is a complete imbalance, the net radiation or imbalance in this heat balance, it will lead to the polar region become cooler and cooler, and some tropical region equatorial part become more hotter and hotter. So there will be no life on the earth. Anyhow, Mother Earth maintain this balance for the good of humanity and other life on the earth. There is a tremendous increase in the greenhouse gases because of certain human activities as well as some natural force. Human activities, mainly anthropogenic activities, which is mainly industrial fossil burning of the fossil fuel, tropical deforestation, transportation, industry, more and more expansion of the urban land, all are causing increasing in the greenhouse gas emission. If we see, recently data suggests that mean annual temperature of the world is already higher by more than 1 degree Celsius from pre-industrial time. That you can see from here, temperature is constantly rising. But when we look at greenhouse gas emission, different country wise, per capita emission from India is least lesser compared to other developed countries like China, USA, Russia, Europe, and so on. So overall, we are not polluting that much what other developed countries are doing, but at the same time, we are large land mass, large population, So we need to adopt certain kind of sustainable lifestyle to curb greenhouse gas emission, and also adopt certain climate resilient and green practice to curb effect on farming and agriculture. Here you can see mean temperature trend over India and global. So you can see here 0.6 degree per year is warming, 0.61 degree is warm over 100 years. So there has been increase overall, all Indian mass, land mass, around 0.6 degree temperature has increased over last 100. It may vary across different locality and a region also, but whole India trend is that 0.6 degree warming is there over last 100. Global mean temperature equally increasing, but it is a little bit okay faster. You can see from 1970 onwards there is a steep rise in the global mean temperature. This may be because of more and more increase in the greenhouse gas concentration in the atmosphere caused by burning of fossil fuel and other anthropogenic activities. Now let us understand, because our topic of today's discussion is agroclimatic risk assessment and climate resilient agriculture. So we need to first understand what is climate change and what is climate variability. Climate variability mainly refers to the variation with respect to space and time. So there is a variability in the climatic element over last 5 years or 10 years with respect to its mean, then you can say it is a climate variability. So there is a variation along the side of mean. So this is called variability. It may be represented as pentate climate variability, decadal climate variability, like that. But climate change refers to the long-term change in the statistic of a climate, or you can say long-term change in the state of the climate, defined by the change in the entire of mean as well as coefficient of variation and anomaly over a longer period of time, at least maybe okay 70 to 100 years. Here you can see with respect to mean, just 50 years back there may be okay climate, 10 years back there may be climate variability like this mean, and also okay 50 years back climate variability is like this, now climate variability like this. So it was here, it is a climate variability if it is for some 5 years, but if you consider this was in 1950 and now it is in 2010 to 2015. So this in 2055 to 2060, and this is 2010 to 2010. That means not 2015. This is 1955 to 1960 and 2010 to 2015. So here you can see 5-year mean is like this for the temperature, and it was varying along the line of the mean. Now this mean temperature line is completely changed. So this you can say climate change. Here it is only the cyclic in nature. It is a climate variation. Now how this will affect the agriculture? Mainly crop require certain kind of heat, water and nutrients. So yield potential of any crop determined by the climatic element and photosynthetic properties of the vegetation crop. That is called theoretical or potential yield. So if there is a water limitation, water, because there will be a increasing frequency of drought in climate change, so there will be a water scarcity. If there is also nutrient limitation, then it will limit the yield of the crop. to almost 5,000 kg per hectare. Initial yield potential is more than around 20 to 20,000 kg per hectare. But because of this limitation, it is what is realized on the farm is 5,000. Further, there are certain reducing factor like pest and disease. So if we do not have kind of protection measure against pest and disease, it and weeds, it further reduced to the 1500 kg per hectare. So this is the actual yield what farmer gets. But potential of that variety or a crop is 20,000 kg. So there is a yield gap. Actual minus potential minus actual. So there is a very large yield gap. This yield gap is widening with the climate change. The climate change is going to increase temperature, reducing water availability, and also affecting the growth and development. So finally, there will be a large scale reduction in the gap, widening of the gap of the yield gap. So mainly here you can see attainable yield of cereal quite satisfactory, mainly in Indo-Gangetic plain. It's quite satisfactory. But Western and Central India, there is a still we need to improve to bridge the yield gap. We have to still do certain kind of more effort, agro technology development to overcome the limitation of the water, nutrient, temperature, and so on. So climate change, how it is affecting India? Mainly warmer season, because there will be a more warmer season, around 2 degree centigrade is predicted by end of century. 1 to 40 degree centigrade is a extreme range which is warming during a season. There will be a increasing in the frequency amount of annual rainfall with precipitation, but at the same time there will be a decrease in the number of rainy days. The intensity of the rain will be very high, but number of days during which rain is received in at a particular location will be very less. So currently you are seeing monsoon pattern. There is a torrential rain, very strong, heavy storm are that impacting in Gujarat, Rajasthan, even our North India, Himachal, Uttarakhand. But this rainfall we are receiving only in a few days, 10 or 15 days. If there is will be another dry spell of 20 days, then this heavy rain will not be utilized by agricultural crop. So this kind of condition will come in the future, that there will be heavy rains accumulated in a few days. So majority of this rain will lost as a overland flow. It will be not used for recharging the soil water to root zone. So crop may not be able to utilize this. So there will be a drought, increase in the frequency of drought, as well as there will be a flood. This both kind of situation will witness year round due to climate change. Then there is a cyclonic disturbance, increase in the storm surge intensity also. Sea level rise will be there. Around 5.7 centimeter will increase by end of 21st century. Sea level rise that may lead to the ingress of seawater, salinity in the coastal agriculture and coastal ecosystem. So that will affect largely to the coastal area. Wastewater supply high variability predicted with respect to the 50% increase or 45% reduction in the 10 to 30% increase risk of the flood. So flood will increase by 10 to 20%. Similarly, drought is also going to increase by 10 to 15%. This is the projection. So projected temperature rise may be by 2 degrees centigrade in the just by end of this decade, by 2023 2030. So let's hope our government of India effort towards curbing climate change through more and more green practice, solar energy, wind energy, also certain kind of natural farming, conservation agriculture, all is pushed heavily by the government of India to curb climate change and also to curb greenhouse gas emission for leading to the climate. How actually this climate change affect the crops? Let us understand that there are two ways. One is because of climate change, will be a rise in the temperature of the earth. Mean air temperature will increase. Secondly, there will be an increase in the uh, um, uh, concentration of greenhouse gases, particularly carbon dioxide in the atmosphere. So first, because of global warming, certain area like polar region or low latitude area where certain crops are not able to grow, they will become more fit or suitable for growing certain crops. But tropical areas where crops are already grown, but they require little bit cooler temperature. So rise in the temperature like wheat crop. If there will be a rise in temperature by 1 degree, it is going to affect yield of the wheat crop by almost half a ton. So there will be increase in temperature, reducing this global warming. Because of this, more longer season will be there, because there is a strong curvilinear relationship between the temperature and rate of development. So if temperature is shoot up, become higher, length of growing season will be shorter. If temperature is cooler, then length of growing season will be longer. So those areas which were cooler, they will get cold limitation will be improved, and then because certain crops which cannot be grown, certain crops are so require certain optimum temperature. Without that, they cannot emerge or they cannot flower. So under those conditions, if cooler temperature prevail, then they will not flower, they will not emerge. So if there is a rise in temperature, it will remove this cold limitation, and those crops may be able to grow there. On contrary, certain crops are cool loving, like apple, which require chilling temperature. So even chilling unit, effective chilling unit around 1000 to 1250 above below 7 degree. So this particular crop require very cool temperature during December to March. So if there is a warming, this crop cannot be grown. It will shift towards the higher latitude. That means it will shift towards the particularly you can say higher elevation, not latitude, higher altitude, higher elevation. Similarly, there will be an increase in frequency of drought. As I already said, there will be an increase in intensity of rainfall, but this rainfall will be concentrated in the few number of rainy days. So more number of days will be there during the growing season without rain. More number of dry days will be there. So there will be an increase in frequency of dry days. As a result, there may be an effect of drought. Increased incidence of pest and disease also. More pest and disease will be there. So that is all temperature effect. Rise in evapotranspiration, more crop water requirement will be also there. So there will be a more drought, because if water requirement is not met, there will be a drought. On other side, because of increasing concentration of atmospheric CO2, it will improve the photosynthetic activity. More amount of carbon dioxide will be available to be supplied at the chlorophyll reaction center in the plant canopy. So more and more CO2 will be delivered at the plant stomatal area cavities. So as a result, more rate of increase in the photosynthetic rate. So more will be the evapotranspiration, because both photosynthetic rate, photosynthesis and evapotranspiration are reciprocal process. One molecule of water H2O get exist, then only one molecule of CO2 get fixed. So evapotranspiration will also increase, crop water demand will also increase. So it is like that, increasing CO2 concentration, productivity may increase, but At the same time, for the certain crop like C3 crops, wheat, rice, and so on, certain crops may not be favored by the increased concentration of CO2 like C4, which are already having higher photosynthetic efficiency, water use efficiency, but they have limitation of certain. These C3 crops will be more supported, but at the same time it will be also affected drastically due to climate change because of high temperature effect. Now this is already we have discussed in last lecture. There means this is the impact of climate change is now surface in form of various natural calamities and extreme weather event occurring all across the world. Whether it is cyclone, floods, declining heat waves, declining the wheat production due to climate change, all is happening in US, Russia, India also. So as I discussed, those countries, developed countries like China, Russia, US, Europe, they are developed countries. They are polluting more, means their contribution to the greenhouse gas emission is more. But they will be not affected more due to climate change. Those countries which have got developing countries are going to be affected more because of climate change. So we don't have that shock absorbing mechanism. We are still growing. We need to develop in terms of the infrastructure and other things. So we need to have this kind of, we immediately cannot have a larger threshold of curbing the emission. So those all developing countries, they still needs certain technology to be transferred from the developed countries for this greenhouse gas emission, curbing greenhouse gas emission and reduction strategy. Now you see here how the agroclimatic risk, which are the area more susceptible to the climate change or climatic risk. Here you see the exposure. These are the area which are highly exposed. The brown means very huge exposure is there, and this green is a very low exposure. So this is a Indo-Gangetic plain. You see highly exposure to the different kind of hazard and that, and then vulnerability, which are more vulnerable. Vulnerable area is Rajasthan, and this Rajasthan is the highest, and also our Uttarakhand. Highest vulnerability to various kind of, not only flood, or all other kind of disaster, cyclone and all different kind of disaster and the extreme weather event. So more vulnerability is there, either drought, flood, cyclone, all different kind of hazard. So Rajasthan and Uttarakhand. Now overall risk, if we see highest risk to climate change, Rajasthan, Indo-Gangetic plain and Uttarakhand. Uttarakhand, Himachal, Jammu Kashmir means northwest India, and also to certain extent this also northeast India, highly susceptible or highly subject to the deeper, high, very huge agroclimatic risk, climate change related and extreme weather event. So it is a drought, floods, chronic unseasonal rain. So sea level is rising, and it is confirmed with the altimetry data. Here you see that by 10 to 90 centimeter, 5 to 30 centimeter by 2050. Temperature rise by 2000 by end of this century around 1.4 to 5.8 across different part of the India globe. And also this is also across different part of the globe. So this all temperature rise, sea level rise, increasing frequency of drought, and also increasing carbon dioxide concentration, methane, increasing this heavy seasonal rain, frequency, intensity of cyclone, all is going to affect one or another way to agriculture. Here you can see these are the different climate projections with respect to the this head CM3 scenario, climate change scenario. Now here you can see average surface temperature that is projected to be increased by 2 to 4 degrees centigrade over India during 2000. But with respect to rainfall, there will be marginal changes in monsoon month and large changes will witness particularly during non-monsoon month. But as I said, number of rainy days, which is very critical, it is said to decrease by more than 15 days. If 15 days dry days increasing in the frequency of dry day during the rainy season may cause substantial reduction in the crop sown area as well as crop production and crop product. So this is very much important that heavy rain, total amount of rain in a year or season, that doesn't matter, that doesn't has much meaning with respect to the agriculture, crop growth and development. If uniformly distributed rainfall received across the season, then only it is useful to the crop. So climate change that will alter the pattern of the distribution of the rain, and finally it is going to affect the agriculture activity. Similarly, cyclonic storm, you see also intensity of rain 1 to 4 mm. There will be increase by 1 to 4 mm. Which heavy intense storm will be there. Wherever there will be a rain, it will be more intense. So more intense rain will create havoc because it may lead to the soil erosion as well as it cause crop lodging, damages at the particular instant of event, as well as it is that water which is received through rain will not be utilized by crop for the evapotranspiration to meet the moisture, soil moisture requirement or irrigation requirement. So this is there are many adverse effect of the heavy rain. It may cause increasing frequency of drought, soil erosion, crop lodging and so on. So here you can see particularly with respect to increasing temperature, temperature will be more. Okay, you see here around 7 point. Okay, this brown is there. Five around 4 to 5 degree increase will be there also in some area. Some by 2041 to 65. Temperature as per one scenario of HCM3. Around 4 to 5, more than 5 degree increase will be there in certain area. Specific to India, I'll show you. Here you can see this is a more warm scenario, anthropogenically emission scenario, and this is a business as usual scenario. This is a monsoonal rainfall, monsoon season rainfall. Now you see here monsoon season rainfall, that is some located place, it is going to be increased. No doubt, it is going to be increased. But temperature especially you can see in this particular anthropogenic more emission scenario, temperature rise will be in around in the northwest India, particularly this northwest Himalaya, Jammu Kashmir, this Himachal and other area. It will be around more than you can say 4 or 5 degree. But business as if there is no warming, nothing or no emission, nothing is there as on today, business as usual, even though there will be a rise of temperature around 3 degree. So northwest Himalaya, there it is going to experience steep warming compared to the peninsular region or Indo-Gangetic plain. So these all will lead to the different kind of effect: higher temperature, alter precipitation, sea level rise, growing frequency, intensity of weather event, drought, flood, and also reducing agricultural productivity, food supply chain, disrupting food supply chain, and displacing communities. So this is rainfall. How over by 2080 there will be very huge rainfall. Temperature also by 2080 very warm temperature will be there, around 4 degree increase in over India. So this is a projection with respect to the 1960 to 1990, 1960 to 90. So there is a projection is there, there will be a warming, and it is a you now witness with the observed data also. Temperature rising is there already with the IMD observation. I have shown that 6 degree over last 100 years, 0.6 degree warming is took place over last 100. Then also you can see how drought will increase, the frequency of drought. You see particularly the very current climate 1961 to 90, but this is a medium emission scenario, low emission scenario. There will be no much increase in the frequency of drought. But medium emission scenario, increase in frequency of drought will be there. All brownish and yellowish area will is increasing. And here you see high emission scenario, mainly in South Africa. There are larger part of the South Africa will experience more number of drought. In India also, there may be okay around 3 to 4 years of drought in a 30 years. So India is also going to affect, but other area they are okay. This area particularly western okay higher latitude. This also okay Africa. This okay particularly South America. They all are going to experience increase in the frequency of drought. So let us talk about the how climate change going to affect the productivity, production, and agriculture commodities. The agriculture commodity are any product which are traded internationally in response to the demand. So climate change going to affect both production and productivity. Finally, it will alter food balance and supply, food security. So this will affect more in the developing countries or least developed countries. Crop yield and climate change effect will vary across different regions and localities. In generally, this productivity increase is going to be observed particularly in the middle to high latitude. And this all depends on the crop type, seasonality, growing season, temperature regime, and monsoonal rainfall. So it depends. Okay, it is not every part of the India or every part of the globe will experience same degree of effect. It depends on the kind of crop is grown, kind of okay growing season, kind of temperature changes or monsoon changes. Mainly in case of cereal, food grain crops, we are seeing when temperature rise will be there around more than 3 degrees Celsius, 4 or 5. There will be a drastic decline in the cereal productivity. Wheat, all cereal productivity will be drastically declined. But more effect will be observed particularly in case of wheat compared to the rice, to major cereal. So here this is one okay geospatial partially explicit information is there for certain crop, maize, soybean, rice and wheat. Which is the country going to affect more with respect to 1 degree increase in the temperature, how their productivity will lead to change. So here you can see for wheat crop, mainly wheat crop, you can see here particular for the wheat crop what you are seeing, mainly India around 10 to 15 10%, means around 10% decline will be there in the productivity with 1 degree temperature rise in future. But comparatively China is going to experience little less, 5 to 6 degree, 5 to 6 percentage. In case of rice, similar trend is also there, but little lesser effect of the climate change on rice. Even in India it will experience around 5% decline in the productivity. China around 3 to 4% decline in the productivity by per 1 degree increase in the temperature from the base. So here similarly okay you can say soybean also, but soybean particularly USA, steep decline will be there in the productivity of soybean. India it is not major grower of this particular soybean crop, but China also not growing much. All this climate change, it is surely now understood that it is going to affect the productivity of different crops. How we can simulate, because now we need to understand how we can simulate the impact of climate change on the productivity of crops. It is not only the geospatial technology, that means remote sensing, GIS or other tool only can work. We need to use certain sophisticated decision support system tool called crop simulation model. Crop simulation models are nothing but inbuilt program that simulate behavior and processes of plant as a function of weather, soil and management conditions. This means all these model require input, weather input in the form of temperature, humidity, solar radiation, rainfall, etc. It requires soil parameter also, texture, depth and some soil fertility. It requires certain crop coefficient, phenological crop coefficient, phenotypic crop coefficient, certain morphological characteristic like initial leaf area, specific leaf area, and so on. It requires also management. We have to at least decide when time of sowing, number of irrigation given, time of fertilizer application, and so on. What kind of process it simulate? Rate of development, different kind of phenological development, timing of occurrence of different stages of crop growth in a life cycle. Carbon assimilation, transpiration, respiration means release of CO2 from the plant canopies to the atmosphere, partitioning. How this occurs? Photosynthesis, which are produced as a process of photosynthesis, are utilized or partitioned into different plant part like flower, seeds, leaves, stem and root. Then dry matter formation, that means biomass formation. Final output will be total biomass, leaf area index on a daily basis, yield, final economic yield, water balance parameter, nitrogen uptake. These are the output it gives. So most of these crop simulation model are experimental model. They are works with the point scale at the particular experimental farm or observatory, but there is always possibility to extend this kind of crop model to large area using spatial perspective power of the GIS and remote sensing. So there are different kind of models. DSET, Decision Support System for Agro Technology Transfer. This is a suite of model. Almost all crops. There are different kind of models are there within the DSET, like cirrus rice, cirrus wheat, cirrus maize, crop grow, cotton, sucrose, and many more. Then there is a World Food Studies WFOST, which is a mainly radiation water-based model. InfoCrop developed by the IIRS, Indian Agriculture Research Institute. EPIC, Erosion Productivity Impact Calculator. ORISA, specifically for rice. Wheat growth, specifically for wheat crop. These are all physically based crop simulation model which simulate crop growth, development, water balance and biomass and final yield. So for partially regionally, these are the model being implemented with the GIS, wheat growth and cirrus wheat rice, infocrop, all have been tried, but all these model are run with the weather parameter. So weather for crop forecasting or weather generator in partial large area, we may not have enough number of observatory network. So we depends on the stochastic weather generator or certain kind of interpolation. But this may not work because we don't have, in India we do not have many number of observatory which are which can generate representative weather condition over the large. As in yesterday lecture I have shown that one example. It is always better to have a more representative, partially representative weather information on a day-to-day basis to improve the crop yield forecast compared to the more accurate weather generation. This is the difference, because observed data give you a more accurate weather, but that weather may not be representative of large area with the one observatory in a one district. So this point we need to understand, because that nowadays there are large number of modeling approach, climate model simulation and climate model runs are there, which provides seasonal weather forecast, seasonal climate long term climate forecast and so on. All these forecast along climate based forecast along with the crop simulation model can be used with the geospatial technology for generating partially explicit information about the crop yield and crop anomaly in the climate change scenario. So this yesterday, as I showed, we can see remote sensing, GIS, crop model and climate model together. We can generate climate change scenario and use those climate scenario to drive the crop model, and then we can visualize this crop model output in a partially explicit form with the remote sensing and GIS. So this is the all power of the three tools to visualize partially climate change impact on the agriculture productivity. So as per this, agriculture productivity, most of the crop, maize, wheat and all crop going to be declining with the temperature will rise above 2 degrees centigrade. So by increasing temperature for 1 degree centigrade, most of the crop will be affected, but at least rice, which will shows effect in temperate condition above beyond 2 degree. Means in temperate region, rice will be shows certain kind of decline, negative effect of the temperature rise beyond 2 degree only. So here you can see 2020, 50 and 80. In 80 there will be a very much, you can say more than 20%, 30%, or more than that, 30% decline in the crop yield, wheat crop yield in India. But same is not there, around 5 to 10% in case of this 5% in 2020. That is all simulated. But here I wanted to highlight mainly northwestern Himalaya, where Indian Institute of Remote Sensing is located. So we have done some case studies to understand how climate change is going to affect in northwest Himalaya. So here you can see climate change is experienced in the northwest Himalaya 1 to 1.5 degree in last 100 years. Next 100 years, 3 to 5 degree rise in the temperature. More than 3 times warming than alluvial plain, Indo-Gangetic plain. More frequent and intense precipitation increase, and all these will affect decline in the yield of crops, shift in the apple cultivation towards higher altitude, increasing in the incidence of pest and disease. So we should know now do with the geospatial technology how this region, as a region, will respond to the climate change, how shifting in the cultivating area, what will be the shift with respect to the land suitability and crop diversification to improve the to have more climate resilient agriculture. So here you see rice and wheat productivity is going to be declined almost all state. These are all different kind of climate global circulation model with the climate change scenario. But overall you are seeing that this wheat crop around 60% decline is there in certain state. Mainly if you see this purple is there, so purple, that means 8CM3 model, it is showing 60% decline in there, particularly in case of this Bihar, Andhra Pradesh and the Bihar, Andhra Pradesh and Bihar. And this particularly this red or mostly that many countries, many states are going to experience decline in the yield of crops, but there are certain states like Maharashtra, there are certain Karnataka. For wheat, there may be not much decline in the yield of crop. Paddy also showing similar kind of trend, but little lesser in with the certain kind of model impact of climate change. So this is one case study. Okay, so epic model we have used for the Dehradun Valley to understand the crop physiology, growth, crop yield, soil carbon sequestration and nutrient. So this is one process based model that can be parameterized and implemented or partially to simulate uh, crop yield, soil erosion and so on. So here you can see this epic model. We have prepared all database partially, and then we have could able to estimate yield, evapotranspiration and water productivity in the climate change scenario. Climate change scenario same 2020, 50 and 2080 at 1 by 1 kilometer grid. First, this model is parameterized with the different crop specific parameter using the actual leaf area index observation and yield. Then those parameterized observation are used, parameterized coefficient are used in the model for whole all 150 grids in the Dehradun Valley. So here you see all grids. We have 1 by 1 kilometer grids. This land use land cover map, soil, and over 1 by 1 kilometer grid. For every square box, we have run the model and simulated the crop yield, leaf area index, and this water balance. Here you see how it is affecting. First, we need to understand how climate change is affecting the productivity. One way, with increasing the CO2 concentration, surely it will improve the crop yield. But here we are seeing there is a decline in yield. So this decline in crop yield is mainly due to intense warming, because there is a curvilinear relationship between temperature and the rate of development. When temperature shoot up, it leads to the shortening of the growing season. As a result, there will be lesser number of days during which photosynthesis will occur and some crop produce will form. So shortening of growing season finally leads to the declining in the crop yield. So here you see different from baseline scenario to up to 2080. This season is reducing one by one. You see 2018, it is reduced by almost 15 to you see 2018 21 days compared to the baseline scenario. Actual 21 days less number of days in a season available for photosynthesis. So finally crop yield will decline. Here you can see rice productivity how it is in baseline scenario 2020, 2050 and 2080. So here you see 80 mostly brown and yellowish. So you are seeing that around 20 to 40% decline in their productivity of rice, and then also wheat. Overall, if we see in both without CO2 fertilization and with CO2 fertilization, without CO2 fertilization there will be a steep decline in the productivity, but that is not the scenario. We already know that carbon dioxide concentration is increasing in the atmosphere. So it is a more or less there it is going to be beneficial to the crops. So overall decline in the productivity will be there little bit lesser compared to the this you see here 2050 and this decline will be there around 55 to 20%. But in case of without fertilization scenario, it is decline will be goes up to even 45%. So without fertilized scenario, highest decline in the productivity of wheat, followed by rice 20%, followed by maize 14%. Because maize is a C4 crops. It has got higher photosynthetic rate, efficiency, and it withstand any extreme weather event. Similarly, for wheat crop in Himachal Pradesh area, similar results also we can see that drastic decline in the productivity of wheat crop in 2020 and 80. For 2050, there will be no declining, but this crop may be favored with the more rainfall that can be used by means winter shower. Increasing the rainfall, winter shower that will help wheat cultivation in Himachal Pradesh. apple. Now this apple cultivating area is moving, shifting of apple belt. It is shifting towards the higher latitude. So with killing unit is declining, so crop productivity is also declining. Another area is also very much important, water availability, which is expressed as a period in terms of water availability, length of growing period, which is calculated based on the rainfall and the potential evapotranspiration. So length of growing period, it begins when rainfall greater than 1/2 pt and ends when rainfall less than 1/2 pt plus number of days required to deplete 100 mm of soil moisture. That can be computed by the number of days during which 100 mm of potential evapotranspiration happen. So here you can see as we go from 1961 to 1970, now this water availability, length of growing period is here very high, and then now it is declining. 2000, okay, 1991 to 2000 decline and decline. So length of growing period is declining, means number of days in terms of water availability declining. So this is a water is the crucial to produce crop. There is a strong linkage between food security and water security. So if water is available, it is directly affecting the prospect of the crop production. So if there is going to be a decline in the natural water availability, it is finally going to affect the food grain production of the Himachal Pradesh. Likewise, land suitability also in Himachal Pradesh, wheat area, suitable area, non-suitable area showing decreasing trend up to 2050 but increasing drastically in 2080. Suitable area for wheat crop will increase up to 2050, then it will declining. This shows that intense warming, then more significant warming will be there. It is going to affect the suitability of wheat cultivation in the Himachal Pradesh or mountainous ecosystem. So there will be no temperature, means cooler temperature will be available, which can uh, enhance area or product growth of and performance of the. So already we know wheat is a cool loving crop, except okay immersion stage. It require little bit okay cooler temperature. Minimum temperature is cooler, but here it is going to be warmer, so it is going to affect the wheat cultivation. Similarly, in this Western Ghat, okay, Tamil Nadu and other areas where you can see also species-based climate scenario, irrigated rice is going to get little bit less affected compared to the rain-fed rice. Rain-fed rice effect more will be there, okay, declining the yield in the certain area, but here it a little lesser. But surely there will be a negative effect of the climate change on the rain-fed rice yield compared to rain-fed rice. Similarly, all maize, sorghum, and this area, coconut, rain-fed area will be more subject to the decline in the productivity compared to the irrigated. Then irrigated and this rain-fed, you can see rain-fed rice and rain-fed is always okay subject to the more steeper rise in the temperature, and finally it affect the growth process and yield. Northeast also you are seeing irrigated maize. Now rain-fed rice, but here you can see irrigated maize, and here this. But maize, okay, here it is going to affect more in case of northeast. Even it is irrigated, but rain-fed rice, we overall rain-fed cultivation is going to affected more due to climate change. So what I want to convey here is that irrigation, supply of one or more irrigation as an adaptive strategy can reduce negative effect of the climate warming on the crop productivity. So if you have certain kind of water availability, you can always provide one protective irrigation to save your crop as a measure of adaptation. So these are the different adaptation make food supply chain infrastructure more climate resilient. building infrastructure, cold storage facility, rural connectivity, digital service, technologies such as early warning system, extreme climate related event, online agromet weather advisory, forecasting service, all can help farmer because advanced advanced early warning for the any episodic event can help farmer to take certain contingency measure or advancedly drought proofing measure or certain advanced planning to avoid negative effect of this aberrant weather condition. Remote sensing can provide land use planning and management as well as integrating this natural resource, mainly water management concept, is much more important to reduce the greenhouse gas emission. Finally, now government of India is pushing the natural farming, organic farming, some kind of nature-based solution, conservation agriculture to increase the more and more storage of the carbon into the soil, more sequestration by the certain natural plant species, finally generating the increase the biodiversity and finally leading to decline in the climate change and greenhouse gas emission. So here you see adaptation strategy. One example is there that different in Ludhiana, Raipur, Akola, different kind of district 2025, 25, 50 and 75 with different kind of models are there. These are the four different kind of models, but here you can see negative yield is declining during the 2025 to 50 and this with rise in the temperature without adaptation. If there is no adaptation mechanism, agronomic strategy or anything applied, then there will be surely a decline in the yield of crop. But the moment same area, if we apply one adaptation, 3 advanced sowing in response to 200% rise increase in the fertilizer and 1 irrigation. If we apply doubling of the fertilizer dose, advancement of the sowing of the wheat crop, we advance it by 15 days, early sowing, twice fertilization of the urea and giving one more extra irrigation that helps to overcome this negative effect of the climate change and translate it into a positive yield. So now you see these are the adaptation. If we make this agronomic adaptation, then there will be a rise increasing in the yield of the crop compared to the control. Similarly, water requirement also, from viewpoint of water requirement, there is going to be a drastic increase in the water requirement of the crops, particularly sorghum or other crops also, both in Rabi season as well as Kharif season also. You can see there will be a rise in the from 1981 to 2050 and up to 2080. There will be a rise in the water requirement of the crops. These are all projection based on the climate change scenario. But we can restrict this rise in the water requirement and so on with the more and more curbing greenhouse gases through certain regenerative agriculture, or you can say through adoption of renewable source of energy, more biomass related energy and so on. So these are certain example of the crop water requirement on ground base carried out by Central Research Institute for Dryland Agriculture, ICR. Here you see they have evaluated how this adaptation, advanced planting. If you advance sowing or planting of the mustard crop, wheat crop and chick crop, it will lead to the increase in yield because advancement of the crop sowing can lead to the more availability of cooler temperature during the growing season, and so we can avoid large intense heat stress during the critical period of the grain formation. Now here you see for satellite observation, all those solar energy map like solar potential solar energy utilization hotspot and solar utilization maps and wind power related energy maps, all are very much useful and can be possible to generate to provide solution related to clean energy and value product for energy mapping and other things, mainly particular for renewable energy potential hydropower geothermal and solar energy. We can identify which are the site where we can generate more and more solar energy, like Adani Power. There is okay in Gujarat, some area like Kutch, Bhuj. There is a one energy company is there. There are so many windmills are. So that is all generating large scale wind power related energy. Similarly, okay, in Rajasthan, as a Jaisalmer area, other area, there are many solar plant and wind power. Jaisalmer wind power is there. Wind power relay plant. Many places, most of the government institutes also put certain protocol of generating more solar based energy. So even solar based groundwater pump are available. So all this is going to happen, reduce the coal based energy, and we are using more and more renewable source of energy to reduce the greenhouse gas emission. And finally, we can achieve net zero emission from agriculture. So like this, okay, in our NRSE, there is a Bhuvan portal. Now biomass maps are produced. So we can track biomass, which are the best crops are there, which can provide higher biomass for generating biofuel energy, or we can also use those crops as a measure for the carbon sequestration and so on. So these are the maps all can be generated with the satellite data, GIS, and other ground-based observation.